Hello everybody, welcome to this next video. So in this series we are solving problems from different competitions in mathematics around the world. So this is a problem from COMC 2020 2, and here we have this problem. It's simple. It is related to quadratic equations. So if you look at the problem, find all integer values of a such that this equation does not have real solutions in x, right? So let us do the first part. It is asking us, like, for what integer value of a this equation does not have a solution, okay, real solution. So we already know that whenever we are trying to do something with the solutions of a quadratic equation, we have to look at something called discriminant. So this is defined as like coefficient of x, which is a here, that square, minus 4 times coefficient of x square, which is 1 here, times the constant term, which is 1. So this is a square minus 1 minus 4, right? And we know that if discriminant, let me call it as d, is less than 0, then the quadratic equation has no real solution. Quadratic equation has no real solution. Therefore, we write a square minus 4 less than 0. Okay, so what value you will get for your a? So this says a square less than 4. So basically, you want a square to be less than 4. So 0 satisfies a square less than 4. 1 satisfies a square less than 4. Minus 1 satisfies a square less than 4. And then you have 2, and then you have minus 2. This will make a square is equal to 4, and this will make a square is equal to 4. And since we are looking only for the integer values, so our answer will be a is equal to minus 1, a is equal to 0, and a is equal to 1. So the three possible values of which a can take for this equation to not to have any real solution, these are the values minus 1, 0, and 1. Okay, so that's your answer. Now look at the second problem. That's interesting. Find all pairs of the integer a comma b such that both these equations have no real solutions. Okay. Now if you try to do this problem like on the similar lines, so we have x square plus ax plus b equals to 0. That's your one equation. Then you have x square plus bx plus a equals to 0. That's your another equation. Now we want both of them should not have a solution. So here if you compute the discriminant, that will be a square minus 4 times coefficient of x, which is 1, times coefficient of like constant term, that is b. So this is a square minus 4b. And here if you try to find out the discriminant, so that will be coefficient of x, which is b square minus 4 times the constant term, which is 1, times, sorry, the coefficient of x, which is 1, times the constant term. So this is b square minus 4a. Now I want a square minus 4b to be less than 0 and b square minus 4a less than 0. Okay, because I want like both of these equations should not have a solution. So I want this a square minus 4b less than 0 and b square minus 4a less than 0. Okay, so I'm looking for integer solutions to these two inequalities, right? So what you can do here is, like, if you try to do your algebra, that is one thing, right? So what we can do here is you can try, okay, so here a square is less than 4b and here you have b square less than 4a. So from here you can see that b is greater than like a square. 4 times b is greater than a square. That implies b is positive. Okay, and similarly here a is greater than b square times, like, divided by 4. So this implies a is positive, right? So therefore both a and b are positive. Both a and b are positive. Okay, so this is the one thing we have. So if both a and b are positive, so what I can do, I can multiply these two inequalities. So it means that this is positive, this is positive, this is positive, this is positive. So all the terms involved in these two inequalities, are positive. Therefore, I can multiply these inequalities. Therefore, I can multiply these inequalities. And if you multiply these inequalities, what you get? A square times b square, that is on your left hand side, less than 4b times 4a. So you get a square b square less than 16ab. So that gives you ab less than 16. Okay, so you get this. So if ab is less than 16, that means at least one of a or b should be less than 16, because if both are greater than less than 4, because if both are greater than 4, then their product is greater than 16 for sure, right? So at least one of them has to be less than 4. So now if a is less than 4, then from here you'll have let me call it star, let me call it double star. Then double star implies that b square is less than 4 times 4, so that gives you b is less than 4. Okay, similarly if b is less than 4, because we are saying one of them has to be less than 4, so if a is less than 4, we get that b is also less than 4. And if b is less than 4, then star implies a square is less than 16, so that gives a less than 4. So in a sense, we get that a is less than 4 and b is less than 4, right? And okay, so a is less than 4, b is less than 4. So that means what are the choices we have? For a we have 0, 1, 2, 3, and for b we have 0, 1, 2, 3. But we have to see further. So this is my a, this is my b. So this is 0, 1, 2, 3, 1, 2, 3. Okay, so this is like we have the possible points are this. Let me make a different color. So 0, 0, then you have 0, 1, 0, 2, 0, 3. Similarly, you have this. These are the possible points. Okay, but we have to like further see whether we are getting what we want or not. So our equations were x square plus ax plus b equals to 0, x square plus bx plus a is equal to 0, right? We want like both of them should not have any solution. Now when a is 0, in that case x square plus b equal to 0, the first equation is this. It definitely has a solution. Why? Because b is positive, right? So I'm sorry, yeah, when a is 0, it doesn't have a solution, I'm sorry, because b is positive, definitely has no solution. But in that case, what will happen to this? This will be x square plus bx is equal to 0. So you have x plus b is equal to 0, x is equal to 0 minus b. These are the solutions. So that means we are not looking for the points where a is 0. So this is gone, this is gone, this is gone, and this is gone. Okay, so this is not, although we get them from here, but this whole line is gone. And similarly, when b is 0, in that case, what you'll get? You'll get x square plus ax is equal to 0. You put b is equal to 0 here. So x plus a is equal to 0. So you are getting two solutions again. It means that wherever b is 0, we don't want it. So this is gone, and this is gone. Right? And now when if you look at this point 1 comma 2, when a is 1 and b is 2, right? And you already had these equations, right? A square is less than 4b and b square is less than 4a. In that case, what will happen? So this is the point I'm talking about. Okay, this point 1, 2. So in that case, you see, this gives you 1 is less than 8, that's okay. But this gives you 4 is less than 4. So this point is also gone. This point here is gone. And similarly, you can prove this point goes away, this point goes away, this point goes away, this point goes away, and this point goes away. So you are left with only these 3 points, 1 1, 2 2, 3 3. So your answer will be 1 1. So the answer is, the possible pairs are 1 1, 2 2, and 3 3. Okay, so that's how you solve this problem. So now if you look at this problem, this involves like lots of calculations. Okay, but this is how it is. I will tell you a shortcut also, like graphically we can do it. At the end of the video we'll do that. Now if you look at the C part, how many ordered pairs a comma b of positive integers satisfying a less than is equal to 8 and b less than equal to 8 are there, such that each equation has two unique real solutions, right? So you have x square plus ax plus b, same equations, but now you want them to have a solution, right? So we have this x square plus ax plus b equal to 0, and then you have x square plus bx plus a equals to 0. So you want them to have solutions. So basically we want discriminant to be greater than 0. Okay, so you have like here the discriminant is a square minus 4b, and here the discriminant is b square minus 4a. So you want a square minus 4b to be greater than 0, and you want b square minus 4a greater than 0. So from here you get a square greater than 4b, and from here you get b square greater than 4a, right? So like as we did in the previous case. So from here, so we can just multiply all your equations, right? So you'll get, if you read your statement again, okay, positive integers. So a and b are already positive, right? In the last case it was not mentioned, but here it is mentioned. So you don't have to be worried about whether your a and b are positive or negative. So if you multiply, what you are going to get, you'll get a square plus a square b square greater than 4a times 4b. So that is ab greater than 16. So it means that at least one of a or b is greater than 4, because if both of them are less than 4, you are getting less than a number less than 16. So if a is greater than 4, then you'll get, if a is greater than 4, from here you'll get b square is greater than 16, so that gives you b greater than 4. And similarly, if b is greater than 4, then from here you'll get a square greater than 16, that gives you a greater than 4. So we can say that a is greater than 4 and b is greater than 4. And also a is less than equal to 8 and b is less than is equal to 8. That is given in this problem statement. Given in problem statement. Okay, so what we get this, that the possible choices for a are, a should be 5 because it's greater than 4 and less than equal to 8. A can be 6, a can be 7, and a can be 8, right? When a is 5, in that case what you have like from here b is greater than, if a is 5, then you have from here, okay, I'm sorry. So from here you have 4b less than 25, so that gives you b less than 25 by 4. And from here you have b square greater than 4 into 5, so that gives you b greater than square root of 20, right? So square root of 20 is 4.47 and this is 6.25, and because we are looking for integers, so integer between 4.47 and 6.25, so it means that b can take values. What are the values b can take? It can take values 5 or 6. And similarly you can perform the calculations here. For 6, your b can take values, if you do this, b can take values 5, 6, 7, 8, and for 7 b can take values 6, 7, 8. Similar calculations you have to do. And for 8 also it can take values 6, 7, 8. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 pairs possible. Okay, so this is how you will deal with this problem. but there is a graphical solution which I would like to discuss. If you like, we had these two, right? A square greater than 4b and b square greater than 4a. And if I try to draw these curves, a square is equal to 4b and b square is equal to 4a, right? In that case, if this is a and this is b, so this is this curve here is, can you tell me what it is? It is b square is equal to 4a, and this curve here is a square is equal to 4b. Okay, so for the first part, this was for the C part, and for the B part we were looking for a square less than 4b and b square less than 4a, right? So now this is my curve, b square is equal to 4a for B part. So this portion below this was your less than 4b. So this portion is here, and a square, this is my a square is equal to 4b, and you can see that this is the common region here. Okay, so if you have, this is your common region, so let me just, this is the common region for these inequalities, right? And if I try to locate the integers, these are the pairs I am getting, 1 1 2 2 and 3 3. And similarly for these two inequalities, this is the common region here. Okay, let me change the color. Okay, so this here is the common region. Okay, and if I try, because I have to bound above from 8, this was given in the problem statement, so I have to just see what are the integers. So these are the integers, 5 comma 6, 5 comma, then 5 comma 5, 5 comma 6. Here you have 6 comma 7, 6 comma 5, 6 comma 7, 6 comma 6, 6 comma 7, and 6 comma 8, and so on. So this is 1 2 3 4 5 6 7 8 9 10 11 12 pairs. Okay, so this is how you can proceed with this problem. So you can see that graphically it's very simple, but then again you should know how to make the graphs. Okay, so thank you for watching. If you have any problems or any comments, please write in the comment box. Okay, keep supporting, subscribe to this channel. Bye.